Now let's do exercise. Okay, exercise question 5. So we do exercise question 5 based on the previous example we just discussed. It's a very similar example. So here we are trying to analyze the business school, actually our business school, CBA. So for CBA, currently we have 5 departments, and each has its own ASC, Administrative Support Coordinator. So mean arrival rate for work order lambda is 5 for management, because management is the largest department. So the work order request arrival rate is 5 per hour. And for other departments, about 3 per hour. So that is arrival rate. And the average time to complete our work is 10 minutes. This is a service time. Again, it's not service rate. This is service time. So what we need to do is perform calculation and compare the average turnaround time. In other words, average time in a system for a centralized system, pulling things together, and a decentralized system, the current system, to see which one is better. Compare the two systems on average turnaround time. So again, we started with a decentralized system, the current system. So in a decentralized system, there are 5 independent MM1 queues. That means these 5 different departments, they don't share server, they don't share resource, they are independent. So there are 5, each of these 5 departments has a MM1 queue. So the arrival rate for management department is different. So that's why we will have to do a separate analysis for management department. Then we do another analysis for the other 4 departments. So let's start with the management department. For management department, this is the MM1 queue. So how do we analyze it? The first thing we need to do, identify lambda, identify mu, and calculate rho. So lambda is 5 per hour. This is giving information. Mu, we don't know. We only know it takes about 10 minutes to process 1 work order. So 10 minutes per work order. This is a service time. So given 10 minutes service time, we can convert to service rate. So 60 divided by 10, which is 6 per hour. So arrival rate is 5 per hour, service rate is 6 per hour. We can calculate rho, which is lambda divided by mu, 5 divided by 6, 0.833. So what do we need? So based on this given information, what we really need is a WS, average turnaround time for management department. So WS is equal to 1 over mu minus lambda. So 1 over 6 minus 5, you get a 1. So how do we interpret a 1? Again, because both lambda and mu are per hour rate, that's why 1 should be interpreted as a 1 not hour, not a 1 minute. So 1 hour, of course, is equal to 60 minutes. So currently, with a decentralized system, the turnaround time for management department is 60 minutes. Now, let's look at the other 4 departments. The other 4 departments, they are all identical because the arrival rate is same for the other 4 departments, and the service rate are the same as well. So that's why we can do one analysis. So for other departments, first thing we need to do is, first of all, for all other departments, they are all using MM1 queuing system. So what is that lambda? Lambda is 3 per hour. So 3 per hour. Mu is the same as management department. Will be 60 divided by 10. 10 is 10 minutes per hour. Divided by 10, so you get 6 per hour. So knowing lambda, knowing mu, we can calculate what is rho. Rho is lambda divided by mu, which is 3 divided by 6.5. Then, given all this information, we can calculate the average turnaround time, which is WS. So WS equal to 1 divided by mu minus lambda, 1 divided by 6 minus 3, so 1 over 3. So how do we interpret 1 over 3? 1/3, because both mu and lambda are per hour rate. That's why 1 over 3 should be interpreted as 1 over 3 hour. We can convert 1 over 3 hour to minutes, which is 20 minutes. So 1/3 hour, so which is 20 minutes. So currently, with a decentralized system, for management department, the turnaround time, the average turnaround time is about 60 minutes. And for other departments, for the other 4 departments, the average turnaround time is 20 minutes. So this is the decentralized systems. So every department is independent. Every department is using independent MM1 cube. Now, let's look at the centralized system. With a centralized system, we pull resource together. That means we pull the 5 ASCs together, they work together, and we will be using 1 queue. So all the work order will come to this queue. It's 1 queue and 5 servers. So it's MM5. So how do we perform the analysis? Again, it takes 4 different steps. Step 1 is about identify lambda and mu. So for the new system, the combined arrival rate, lambda is adding all the lambda together. It's 3 plus 3 plus 3 plus 3 plus 5. So that gave us about 17 per hour. So the arrival rate 17 per hour. So what is mu? Mu is the same. Mu is the same as the previous slide. Is 6 per hour. So mu is 6 per hour. Lambda is 17 per hour. That is step 1. Step 2. We have 5 servers. We have 5 different departments. That's why C equal to 5. 5 departments means 5 servers. So we can calculate rho. Rho is lambda divided by mu. Lambda divided by mu, 17 divided by 6. We got 2.83. Then we go to Appendix C in the textbook. We look for LQ. So based on 2 numbers, based on C equal to 5, 5 servers or 5 departments. And also based on rho. Rho is 2.83. If you check these 2 numbers, 2.83 for rho and C equal to 5, you can find out LQ is equal to 0.241. In this case, I did not take the middle number. I take the close number, which is 0.241. So now we have LQ. We move to step 3. So now with LQ, we can calculate LS, which is the average number of customer in the system. So average number of customer in the system, LS equal to LQ plus rho. LQ is 0.241 plus rho is 2.83. You get 3.071. So this is step 3. The last step is step 4. Step 4 is calculate something we want, which is WS, the average turnaround time. In other words, average time in a system. So WS is LS divided by lambda. So LS is 3.071. Lambda is 17. So do the work, you get 0.181. Again, how do we interpret this number? 0.181, because lambda 17 is 17 per hour. So lambda is a per hour rate. That's why we should interpret this number as 0.181 hour. Of course, you can convert this number to minutes. How do you convert? You use this number times 60, you'll get how many minutes? In this case, 10.84 minutes. So average turnaround time is 10.84 minutes. So for a centralized system, the average turnaround time is 10.84 minutes. If you think about the decentralized system, for management department, the average turnaround time 60 minutes. For other departments, the average turnaround time 20 minutes. With a centralized system, the average turnaround time for all departments is about 10 minutes, a little over 10 minutes, which is much better. Yeah. So with a centralized system, it's better than decentralized system in terms of the time spent in a system.